Okay, the graphs of these three hyperbolic functions then, so sine, cosh and tanh. Now you may think that they might be similar to sine, cos and tan, as they are defined in exactly the same way except that i's are missing. But actually, that's not the case. They look completely different and they don't even repeat. They are not periodic functions. They've lost that property. And the e to the I theta is a periodic function, but e to the theta is not. It is an exponential function. So these look more like kind of an amalgamation of exponential curves than trigonometric curves. So let's start with y equals sine. Now y equals sine of x. Now that is defined as e to the x minus e to the minus x all over 2. So when x is 0, the top of the fraction will be 1 minus 1, which is 0. So it goes through the origin. As x gets really big, this will disappear, because it's e to the minus something really big, so it will go to 0. So we're left with e to the x over 2. So it's going to be an exponential function up towards positive x. And the similar is going to happen at the negative x, except it's going to be a negative exponential function. At minus x, that's going to disappear. This is going to come into play, but of course it's negative, so we're going to get a negative exponential over 2. And we end up with this kind of graph. That's what sine of x looks like. Not only is it not periodic, but it is in fact a one-to-one function completely, which is quite nice to work with. It's not like sine, where you've got to play around a bit when coming to solve equations. So yeah, so that's what the graph of y equals sine of x looks like. It's an odd function, just like sine of x is, and that's quite easy to prove by looking at the definition of, the exponential definition of it. Cosh then, so cosh of x, that's exactly the same, except it's e to the x plus e to the minus x over 2. And when x is 0, we're going to get 1 plus 1 this time. So that's 2, so 2 over 2, so it's actually going to go through 1 on the y-axis. When x gets really big, this again is going to disappear, so we're left with e to the x over 2, so it's going to look very similar to what it does over there. And as x gets really negative, that is going to disappear, and we're going to end up with, again, e to the x over 2. So actually this is symmetrical in the y-axis. So it's going to go up that way, but it doesn't go down like sine does. Instead, it's going to go up this way. And just like cosh is an even function. Okay, it's symmetrical in the y-axis. Again, nice and easy to see. If I change x for minus x, I get the same thing out again. So, even. And finally, tanh. So we have y equals tanh of x. And that was sine over cosh. So that's e to the x minus e to the minus x divided by e to the x plus e to the minus x. That's the definition of tanh. When x is 0, we get 0 on top and 2 on the bottom, so it's going to cross the origin. As x gets really big, that's going to go to 0 and that's going to go to 0, so we're left with e to the x over e to the x. So it's going to tend to 1 as x tends to infinity. So we're going to have a nice horizontal asymptote. And as x tends to negative infinity, these two are going to be going to 0. This one is going to go to e to the x. This is going to go to e to the x. So we're left with minus e to the x over e to the x, which is minus 1. So it's going to tend to minus 1 as x tends to minus infinity. And just like tanh is an odd function. It's going to come up here. It's going to go through that point there, steepest gradient at the origin, and then it's going to start to shallow out again as it tends towards positive infinity. It's going to tend towards 1. And that's the graph of tanh of x. So just to summarise then, I've got all three of these graphs in a smaller form. So we have sinh of x, cosh of x, and tanh of x. I've also taken the time to do their inverses. So because sinh is 1 to 1, you don't have to limit the domain to find the inverse. You can just inverse it. So reflect it in the line y equals x, and you're done. Cosh, however, is not a 1-to-1 function. It's a many-to-one. So we have to limit the domain to be greater than 0. So this is the inverse cosh function. We're missing this branch down here, otherwise it wouldn't be a function. So it's just the upper arm. And inverse tanh looks like this. Again, just reflecting that into the line y equals x, because it is already a 1-to-1 function, so it's all good to go. And I've also got the reciprocals. So the reciprocal of sinh is cosh, and cosh kind of looks like a reciprocal graph. The reciprocal of cosh is sech, and that kind of looks like a normal distribution curve. It's not, but it looks like it might be. And then the reciprocal of tanh is cosh. Okay, and those are the hyperbolic functions and their graphs. Thank you very much.